Alright, so I'm recording. And this is page 3, integrals. So now what we're going to do is we're going to take the integrals. So instead of taking derivatives, we're now going to take integrals. And still we have r of t. So we have a vector function. And what we want to do is we want to take the integral of this. And so if we're going to take the integral of a vector function, we're just going to take that integral to each component of our vector function. So that's all we're doing. It's kind of like, distributing the integral to each component of our vector function. And so that's it. Now it's something that's going to be overly difficult. And so now we're just going to apply that. And for example 4, we're going to evaluate the integral from 1 to 2 of this vector function, t squared I plus t squared to t minus 1j plus t sine pi t k dt. Alright, now there's going to be multiple ways to do a few of these, but I'm going to show you my way, and hopefully your answer works out to mine. If your answer does not work out the same as mine, then ask me a question in class, and so we can fix everything. So let's look at 38. So again, just evaluating the integral, and we're going to first just go ahead and distribute it everywhere. So I'm going to have the integral, I hate when I do that. So we have the integral of 1 from 1 to 2, and then I'm just going to do t squared dt I. I'm going to change the colors just so that you know which one that I'm working with. 1 to 2, t squared to t minus 1, d of t, j, and I have not used, she's pink. Alright, plus the integral from 1 to 2, t sine pi of t k. Oh, let me put the d of t. D of t. K, or dtk. Alright. And so now let's go ahead and take the integral. So the first one's fun because it's easy. So we take the integral of t squared. We're going to get t cubed over 3 dt. Or not dt, I'm sorry. It goes away, and now we're left with the integral, again, from 1 to 2 I. Now, the next one, we want to go ahead and integrate. Now, if you remember, I forget the term that Ms. Kaufman uses. It's a little bit different than the term I use. I use I late. That kind of helps you determine, I don't know why the A is lowercase, but I did that. I late stands for inverse. Then it stands for, logs. Then it stands for algebra. Then it stands for trig. And then it stands for, our exponentials. All right, and we kind of go in that line of how we want to attack it. And so if we ever have inverse or log, we would go ahead and do integration by parts. But, we don't have inverse or log. And anything in the back, the algebra, the trig, or the exponential, if we have it in that form, we have an algebra and a trig, or an algebra and an exponential, or a trig and exponential, then we want to do the tic-tac-toe method. I forget what Ms. Kaufman calls it. Maybe one of y'all can let me know what how she refers to it as. It's not the quilt method, but so it's the same type of way to actually take the integral. But here we have an algebra and an algebra. So what we're going to do is, because it's an algebra and an algebra, I'm going to go ahead and see if I can rewrite it some way. And so that's what I'm going to do. So I'm going to say, you know what? U is going to equal t minus 1, because that's probably the most difficult function part in that middle integral. So that means that du is just going to be dt. And that's great. I have everything to substitute for except for one thing. I don't have anything to take care of this t. So what I can do is I can use this equation that I have, u equals t minus 1, and I can solve that for t. So I can do a substitution. So it's going to give me u plus 1 is equal to t. And now I can substitute in all my parts. And so I'm going to rewrite this. Because I'm using u substitution, I'm going to change the integral. So I'm going to substitute in 1 into my u. And so it's going to be 1 minus 1. So it's going to go from 0 to 2 minus 1, which is 1. Alright, and I'm going to rewrite t. Instead of saying t, I'm going to say u plus 1. And instead of saying the square root of t minus 1, I'm going to say u to the 1/2. And now I have du. And now I'm going to attack this. And so when I attack it, I'm going to go ahead and distribute the u to the 1/2 to both u and 1. So it's going to be u to the 3/2 plus u to the 1/2 du. And now I'm just going to integrate it. So u to the 3/2 is going to be u to the 5/2 times 2/5 plus u to the 3/2 times 2/3. Right? From 0 to 1. Alright, and now let's attack what's in pink, so the k component. So you could do integration by parts, and again, you would more than likely make your ut and your dv sine of pi t. But what I'm going to do is I'm going to go ahead and do that tic-tac-toe method. And again, the integration by parts should give you the same integration as what I'm going to do here. So what the tic-tac-toe method is, you know, that last part for ILATE is algebra, trig, and exponentials. How you want to work is, you know, whatever you want to do algebra in terms of what you're going to take the derivative of, and you want to take either trig or exponential, what you're going to take the integration of. And so you're just going to make it like a little chart. And it's not going to have to be a very big chart because we don't have a lot to do. And our algebra, since we have algebra as t, it's going to go in the middle part. And then the last part is going to be sine of pi t is a trig function. So we're just going to write sine of pi t. All right. This is going to be where the outside, so this is where we're going to integrate, and this is where we're going to take the derivative. So let's go ahead and do that. So derivative of t is 1, derivative of 1 is 0. The integration of sine of pi t is going to be negative 1 over pi cosine of pi t. And then if I integrate another time, it's going to be negative 1 over pi squared sine of pi t. And the reason I have this part on the outside is just it alternates from positive to negative, positive to negative. And now what we can do is we just take the diagonals, all right? And so now after taking the diagonals, I can rewrite this to be plus, and this does the integration for me. So I'm just going to say, all right, so it's going to be plus, so it's like taking all of this part right there. So plus t times negative 1 over pi, so I'm going to go ahead and say minus t over pi cosine of pi t. And then I'll take the next part. And since I have two negatives, it's going to be positive, so plus. And, all right, plus just 1 over pi squared sine of pi t. All right, and what I'm going to do is I'm going to keep the minus sign in front, but I'm going to also put a plus sign I'm just going to include that right here from integration because I don't want people to get confused that, oh, hey, I need to distribute that negative throughout. And so we didn't do any u substitution, so our integral is still from 1 to 2. All right. All right. Now I'm going to bring down what's in blue, and we're going to go ahead and substitute everything in. So I have t cubed over 3 from 2 to 1. I forgot to put my k down, and I forgot to put my, oops, that's not k, that is j. I have to put my j down, and then forgot to put the k down. So there's k. And now let's go ahead and do the work. So again, if you use integration by parts for what's in pink, it's going to give you the same exact thing. All right. Some people just prefer the tic-tac-toe method because it's a little bit faster, and it's not it's not really too difficult if you know what you're doing. But again, if you do the integration by parts, you're going to get the same exact thing that we got in pink. All right, so now what we're going to do is we're going to go ahead and plug in our values. So I'm going to put everything now in red because we've done all the integration. And so I'm going to go ahead and do 2 cubed, which is going to give me 8. So 8 over 3 minus, plug in 1, so minus 1/3 I, plus, now I'm going to plug in my 1, and so I'm going to have 2/5 plus 2/3 minus just 0 j, because we're substituting in 0 for both of those, and then plus, and then substitute in 2. So I'm going to have minus 2 over pi, or negative 2 over pi, cosine of 2 pi, plus 1 over pi squared, sine of 2 pi, and then minus negative 1 over pi cosine of pi plus 1 over pi squared sine of pi. Alright, so on the left we have 8/3 minus 1/3 is going to be 7/3 I. 2/5 plus 2/3. Get a common denominator 15, so 3 times 2 is 6, 5 times 2 is 10. 10 plus 6 is 16 over 15 j. And then we still got to do all of our trig. So we're going to have cosine of 2 pi is just 1. So we're going to have negative 2 pi, negative 2 over pi, plus sine of 2 pi is just 0. So 0 minus, and then we have negative 1 over pi times cosine pi. So that's going to be positive 1. And then again, we're going to have another 0. So, I'm sorry, positive 1 over pi. So let me make sure I fix that. So 1 over pi plus 0. And so that's k. And so we have 7/3 I plus 16 over 15 j. Not plus, but minus. Looks like 3 over pi. Minus 3 over pi. Okay. And there we went ahead and integrated our vector function. And we are finished. All right.